Welcome to my channel. Today we are going to discuss about the convolutional decoding. We have two methods for decoding the convolutional codes. One is maximum likely decoding, which we call as the Viterbi algorithm. Already the video is uploaded long back. Now we'll talk about sequential decoding. In that again we have two algorithms. One is a Fano algorithm and there is a stack algorithm. In this video we are going to discuss about the stack algorithm. It is also called as ZJ algorithm, stack algorithm. Sequential decoding is mainly used as an approximate decoding algorithm for long constraint length convolution codes. This approach may not be so accurate as the Viterbi algorithm, but can save a substantial amount of computer memory. Whenever you want, you can pause the video and note down. Prerequisite: one should know convolutional coding. He should be able to draw a tree diagram. Example of a tree diagram: I have taken a generator polynomial 111, G2 as a 101, half rate I have taken, and this is a one sample tree diagram has been drawn now. So before you proceed, my suggestion is please try to learn the tree diagram how to draw, because it is a prerequisite for the algorithm. Now I am taking a example: G1 equal to 110, G2 equal to 101, G3 equal to 111. Now draw the tree diagram for this. Pause the video, draw the tree diagram for this given G1, G2 and G3. This is a tree diagram for a given G1, G2, G3, and we have taken a length 5. This is a beginning step. You should keep it ready before we start the algorithm. Pause the video, complete the work. Example for stack algorithm, numerical example we will take. Just now I told G1, G2, G3. Let us take the same G1, G2, G3. Consider I have received 010010001. This is what I have received bit stream. First, tree diagram should be ready for a given G. Then the channel transition probability is given by the equation you have to remember. Or it can be rewritten as like this, where probability of R1 given V1 is a channel transition probability. Probability of R1 is a channel output symbol probability. And capital R is a encoder rate. This is a tree diagram for your reference. Hope you can compare. You have written the same thing. You can compare tree diagram written by you and this. ZJ algorithm. For a binary, probability of R1 equal to 0. Say probability of R1 equal to 1 equal to half. Say it's a binary symmetric channel we are taking. And M of R1 given V1. Say R1 is transmitted, but V1 is received. V1 is not equal to R1. This is a equation. Similarly, whatever is transmitted, if it is written as it is a equation. This can be rewritten as just it is a rewritten, and you can pause the video, you can note down. Now considering the binary symmetric channel, R equal to 1 by 3 and P equal to 0.10, you can pause the video and calculate R1 given V1 equal to, using this equation, fill these values and you will get a minus 2.65. And again fill the values in this equation, you will get a plus 0.52. Multiply by 1.9 nearly, it becomes minus 5 and plus 1. So let us make this as a one integer number, a full number, so that it will be easy for a further discussion and calculation. Pause the video, check it, Are you getting the same answer or not before you proceed? In JJ or stack algorithm, an ordered list of, or you can say stack of a previously examined path of a different length is kept on the storage. Why it is called a stack? All of us know. We have discussed like a push and pop stack. So the same concept here also we maintain the stack. Each stack entry contains a path along with its metric. The path with the largest metric is placed on the top and others are listed in the order of decreasing metric. So just go through, read it twice. You can pause and read it twice. Now, each decoding step consists of extending the top path. Always we choose a top path, we extend it by computing the branch matrix of its 2 raised to k succeeding branches. If it is a binary, hardly will take a 2, 0 or 1. Then adding these to the metric of the top path and form the 2 raised to q k new paths. It's a 2 only we take. The top path is then deleted from the stack, its successor are inserted, and the stack is arranged in order of decreasing metric values. When the top path in the stack is at the end of the tree, the algorithm terminates. You can just pause the video, read it twice. If you understand well and good, otherwise also don't worry. We are going to discuss a numerical example, what you have taken in the previous slide. Then you can come back to the algorithm so that you can understand algorithm completely. This is stack algorithm. Again the same thing is written. Just go through, load the stack with the origin node in the tree, whose matrix is taken to be 0, compute the matrix of the successor of the top of the path in the stack, delete the top path and insert the new path. The same procedure is given from the book as it is. And when algorithm terminates the top path in the stack taken as a decoded path, the same thing is given in terms of flowchart. You can read these steps if you understand well and good. Otherwise also don't worry. Numerical example you'll understand. Then you can come back and go through the algorithm. The same thing is written in the flowchart form for your convenience. Just pause the video, go through the flowchart. It's the same steps what you have taken in the algorithm. Now coming back to the numerical example, we have taken G1, G2, G3 is and tree diagram is ready. Received is also here considered. In the tree, first we have a 1, 1, 1, we have a 0, 0, 0. But received is 0, 1, 0. Let us compare and find the Hamming distance. Now what I am doing, 0, 1, 0, intentionally I have made the color change so that you can understand. Received is this. And on the tree diagram I have 1, 1, 1, 0, 0, 0. Just find out whether 0, 0 is there. No. 0, 1 is there, minus 5. 1, 1 is there, plus 1. 0, 1 is there, minus 5. When there is a difference, received is different, sent is different, minus 5. Whatever is sent, if I receive the same thing, it is a 1. Using that, I am calculating this. Pause the video, try to understand. Second case, 0 is received, 0 is transmitted, 1 is sent, 0 is received. That's why plus 1, minus 5, plus 1. Now I got minus 9, minus 3. I am arranging them. This is a now stack. Select the optimum and continue the same operation. Now what I do, I consider minus 3. Then again I have a 0 and 1 here. Received is what? 0, 1, 0. Now second also. Compare this 0, 1 with these two. Find out along with the previous metric. Now 0, 1, 0 is sent. Received is 1, 1, 1. Minus 5 plus 1 minus 5 because two are different. Middle 1, 1 is received as it is. Therefore, previous minus 3 you have to consider. You have to calculate total. Similarly, pause the video. Calculate for 0, 1, 0, 0, 0, 0 considering the previous minus 3. You can take 1 minute and do it fast. If you do parallelly, you will get a confidence that you can do it in the exam also. Now the answers are, I got this is a minus 2, this is a minus 6. If your answer are also same, very good. Again arrange them. Now again select the top of the stack. Again continue the Same operation. You pause the video and do it yourself. Now I am considering the third residue is 001, but on the tree diagram I have 111000. Again I am comparing. Again total you calculate considering the -6 previous value and write down the answers. Pause the video, do it fast. Again arrange them in the order. Again select the top of the stack. It is the same procedure what you are going to repeat. I have done it. I got -15, -9. Again I have arranged them in the order. Again top of the stack I am taking. Again I am continuing. Now this time received is what? Received is 110 and compare with the 111000 depending upon whatever is there on the tree diagram. Again calculate the values. Again arrange them in the order. Again choose top of the stack. Again continue the same operation. So let us go to the next. What I have got the answer, I will show you. You can pause the video and calculate. Now I will show you my answers. I got -12 and -18 I got. Again I am arranging them in the order. I got -9. Now this is having -9. I have to continue here. Interesting is when I am continuing here, data I cannot take this next. A second data only I have to take. Observe carefully and understand. Now I am coming back. Now only one is what I have decided. Their metric is -9. Now data I have to consider this. And again compare with the 111000. Find out the metric. Pause the video, do it. I will show you the answer. I got the answers -24 and -6. I had this already in the stack. Again considering these two I am rewriting. I got -6 as a top of the stack. Again extend -6. 0 or 1. Received is now 001. Next step. Follow the same procedure. Calculate. Pause the video and you can compare the answer. -6 I have to extend. Again 0 or 1 in the tree diagram. Again I am writing the metric. Again I am keeping them in the order and I got the answers as -3 and -21. -3 and -21. Again I am arranging. This should be -3 I got. Continue the same operation. Again check. Next 0 and 1. Calculate. Now the received will be 110 and compare with the 001 and 110. Write on the metric considering the previous value. Pause the video, do it. I will show my answers. I got -18 and 0. Again keep them in the order. Again extend the next one. Hope all of you are following. If you are not following, you can just pause the video, go back and try to repeat the calculations. You will understand better. Now this procedure I am continuing. Up to 7 I have shown. Now it is 8. Again extend this 0. I am taking 100 is received. Again the 2 I have to compare, the answers I have to check and again keep them in the order. And step 8 I got 1101 as a +3 kept in the order. Remaining 2 are there. I have to follow the same procedure for that also. Step number 9 I have a +3. Again you compare the same procedure. 101 and 101, but consider previous 3 also. Calculate. So like this, when you do it, this step number 9, you can pause and you can check, cross verify your answer. Whatever I am getting, this top of the stack is very important. Similarly, step number 10 I am following the same procedure. Again I am finding step number 9, 10 as a 1110100 I got. Now this I am writing, received is this, and decoding is a 1110100. So this is summary for each step what I got up to 10th step. Pause the video, you can revise the video and try to understand. This is the code received is this. These are the steps what we did it. At the end we got the answer as a 1110100 as an answer. Now we can go back and go through the stack algorithm. What all we have done. Numerically, the same steps are given. You can understand better now compared to the previous case. It's very easy because you have done it numerically. It's easy to, like a reverse engineering. You can understand the algorithm better. Thank you.